All right. Okay, but we do know the y-intercept. What about the x-intercepts? Well, that's this slide. And now I use the quadratic formula. You know, that's what I did. You know, remember, this is the quadratic formula, right? Where the quadratic function, you know, you have a, b, and c. You plug in a, b, and c. That's what we do here. Okay. You know, you plug it in, you get -8 plus or minus the square root of h squared minus 4 times 2 times -3, which is all this. So we end up with this thing. The rest of it here, right? Remember, we get two solutions, right? We have plus, we have minus, the other solution. For each one here, though, what I did was I used a calculator. Mostly because the square root of 88, that's not an easy number. So. Also, I said something about discriminant last time. I think it was last time. This is what I was referring to, the b squared minus 4ac. So just reminding. I mean, here I would just dive in and consider the x-intercepts. So that's what these numbers are. I mean, they're not so nice. They're decimals, but that's okay. So taking everything together, we have our x-intercepts, right? Here's the smaller one. Here's the bigger one. And again, that's where the graph intersects the x-axis, right? I mean, the y-coordinate of those points are 0. Every point on the x-axis is. Our y-intercept, we said, was -3, right? That means the graph passes through the y-axis at the point 0, -3. Here's our vertex down there. And again, I didn't draw the axis of symmetry. Let me see if I can draw it here. 1 second, please. Let me just draw the axis of symmetry. If I can. There you are. It's hard to see the cursor. But again, I know it's a little, oh, geez. Well, I guess this is okay. Hopefully you can see that the graph would be symmetric about this dashed line. So, I mean, I know the arrows aren't here, but again, if you forget to draw the arrows, that's fine. So, and the range, as I said, is -11 to infinity. As you can see, again, if you were to use what we did just before, you know, if you draw this horizontal line to -11, you can see that you can draw horizontal lines from the y-axis to the graph, right? So in other words, the graph is to the left of the y-axis, and then eventually the graph is to the right and left of the y-axis from -11, and it keeps on going up to infinity. Okay, so I think someone had a question.
Yeah, I was wondering, why do we use the quadratic equation to find the x-intercepts?
You mean the quadratic formula?
Yeah, excuse me.
That's okay. I mean, that's what you can just use. That they always give you the solutions to f of the function equal to 0. You can always use that for a quadratic equation.
So isn't it though like the x-intercepts is when y equals 0 though?
But y is equal. But the understanding though is that y is equal to f of x with functions. Here, let me show you.
Right.
In other words, in the background, we do have y equal to f of x. That's understood with the notation. And f of x, I'm telling you, is equal to this. So
okay.
This is based, I didn't write this out before, but it's really understood in the background, though. If that does that, I hope that makes sense.
Yeah, no, I know that part.
Okay. So basically, we have y equal to 0, meaning this quadratic equation will equal to 0, and that's what the quadratic formula gives us the solutions to, this equation.
Okay.
I hope that helps.
Yeah, thank you.
You're welcome. Okay. Any other questions, though? I mean, you don't always have to use the quadratic formula. Depending on the quadratic function, you can, if you wanted to, you can factor. I mean, for that one, I just dived right into the quadratic formula. So, all right. Are there any other questions, though? Also note that if the quadratic formula, if we got the square root of a negative here, so if you can imagine getting the square root of minus 88, right? Instead of 88, that would tell us the x-intercepts are not real numbers. And in that case, the graph would not intersect the x-axis at all. Yeah, that's just something I wanted to point out. Okay, let's take a quick look at the next example. I mean, we have like a minute left, but I'm going to go through this example next time as well. But in this case, notice that a is negative. So that tells us right away the graph is going to open downward. Okay? Since we have A, B, and C, just like before, we have to get the vertex. So we use this formula, the negative b over 2a. Right? If we plug it in, we end up getting, it looks like 3. And then we do f of that. You know what? Let me stop here because we have like 30 seconds left. I don't want to rush through an example in 30 seconds because I don't think any of us will benefit from that.